in this video, we are going to create a scatter plot, find the correlation coefficient, test the null hypothesis, rho correlation is equal to 0, find the equation of regression, test the hypothesis that the beta 1 is equal to 0, find the 95% confidence interval for beta 1, find the 95% confidence interval for the true mean value of y when x is equal to 3, find the 95% confidence interval for the difference between the true mean value of y when x1 is 3 and true mean value of y when x2 is equal to -2. We're going to find the residuals and their standard error, plot the residual against the ordered values of x, plot the residual against the fitted values, and plot the normal probability of residuals. Now I want to keep this video short, so I'm going to do most of these, well, all of them in SAS, and I'm going to show you G and H by hand just to give you a little better understanding of how you solve those parts. And we have data, it's just made up numbers. There's 11 observations. We're just going to call it X and Y and just keep it simple and focus on the concept and how we could produce all of these items in SAS. So here's our SAS code. We have the data step with we're calling example with the input of X and Y, and the data is listed right here. And we're going to go ahead and run this. And now we're going to go ahead and find our scatter plot, which was part A. So we're going to use proc-sgplot, tell SAS that we want to use data from our example set, and X on the x-axis and y conveniently on the y-axis. We'll run that. Okay, and now we have our scatter plot, and we went ahead and ran it as a regression so we could kind of see how the data is falling, if it looks linear, if there's any kind of pattern going on. So sample size is pretty small, so maybe there is a pattern, but right now we're going to go ahead and just focus on the linear relationship. And it looks like as x increases, y also increases, so we got some kind of positive relationship. We're just going to stick with that for now. Next, we're going to find the correlation coefficient. So back to our SAS code, and right here we're going to also test for the null hypothesis that rho correlation coefficient equal to 0. Here's the result, and we have a correlation of 0.95, and this indicates that there is a positive linear relationship, and that looks pretty strong between x and y. Now if we test the null hypothesis that the correlation is equal to 0, we see that our p-value is highly significant. This means that there's strong evidence suggesting that the correlation is not equal to 0. If we go over to our Word document, we see we already have worked out right there. This is how a nice presentation, and the null hypothesis equal to 0 is rejected, and p-value is less than 0.001. Now the next part, we want to find the equation of regression. In the SAS code, we're going to go ahead and tackle several of these parts. So let's go over to SAS and the code. We're going to go ahead and use proc-reg. Data is example. That's where our data is stored under. Example, our model is y equal to x. That's because that's what our variables are named, y and x, and we're going to get our confidence intervals for the beta, and we're going to output out the predicted values, the fitted values, the confidence interval and residual, and the residual standard error. We're going to plot the residuals against x, the residuals against the fitted, and the normal probability plot. Here's the result. We have our ANOVA table. It shows that we got overall significance, so that is good. R squared is 0.9. R squared is 0.91, meaning that 91% of the variability is explained in y is explained by x. And our MSE here is 2.36. That looks pretty low. And here is what we're looking for to answer part D, the equation of regression. We can also answer part E with that table. So our equation of regression is going to be y hat equal to 9.27 plus 1.44x. So to show you that here, let's go to Word. And there we go. Y hat equal to 9.27 plus 1.44x. So now we're going to also use our parameter estimates table to test the null hypothesis that beta 1 equal to 0. And so we see here that x in our model is highly significant. So that means that there's evidence that beta 1 for x is different or not equal to 0. And in part F, we are asked to find the 95% confidence interval or limits for beta 1. And that is right here. So we are 95% confident that the true value for beta 1 is between 1.11 and 1.77. Next is part G. We're going to find the 95% confidence interval for the true mean value of y when x is equal to 3. So I'm going to show you that by hand. We scroll back down here. We have our equation of regression, which is y hat is equal to 9.27 plus 1.44x, and we want to know what that y hat is when x equals 3. So we're going to go ahead and plug in 3, and we get 13.59. Now, to get the 95% confidence interval for the true mean value of y when x is equal to 3, we're going to need the standard error, because you know the formula for confidence intervals is always the mean plus or minus your test statistic times the standard error. So we're going to use this formula for the standard error. I'm going to show you now how you can get these numbers by hand. We're going to go ahead and use the MSE from the ANOVA table in SAS, and that is right here. There you go. So that part is nice and easy. The rest I'd like to show you in Excel. Let's go back to Excel. So I inputted all of the x and y's. We need the mean of x, so that is equal to the average of all the x's, all 11, and the average is 0. Now we need to I'm going to do this each part by part, and x minus the mean. We need x minus the mean. Make sure that you freeze that cell. There we go. Now we want to square that difference. And then we'll do this column summed up. This is going to give us the denominator underneath our square root. So the other parts to this, we will need 1 over n which is equal to 1 over 11. We have this right here is going to be equal to 3 minus 0, our mean, and all of that squared. And then this corresponds to this cell right here. That's just going to be equal to that. Okay, now we're going to find the standard error. So that's equal to the square root of 2.36, which was our MSE. You'll get that in your ANOVA table when you run your regression in SAS. And that is times our 1 over n plus our x naught minus x bar squared divided by the sum of the differences of each xi minus the mean squared. That's that there. And go ahead and close that up. And we get 0.6385, same here as when we did by hand here. So now we want the confidence interval. And that is going to be this value, our y hat, and plus or minus 2.262 times 0.38 for standard error. And we're going to get these values. So if we'd like to check that quickly in Excel, here you can see I have my formula, and you hit enter, you get 12.14. Similarly, change that to a plus, and 15.03. Now if we go in SAS, we ran that big chunk of code. If you go to the line where we have 13, you'll see here that the lower bound and upper bound in our confidence interval when x equals 3 is 12.137, which is about 12.14, and 15.026, or about 15.03, and that matches the work here. So that is good. To our problem here, and in part H, we want to find the 95% confidence interval for the difference between the true mean value of y when x1 is 3 and the true mean value of y when x2 equals minus 2. So showing you that by hand here, we start off by plugging in the values that we're comparing of x into our regression equation, which is y hat equals beta naught plus beta 1x. So here when x equals 3, we plug it in. Similarly, x equals negative 2, and we're looking for the difference. So we want to subtract the beta naught plus beta 1 times 3, which is when x equals 3, minus beta naught plus beta 1 times negative 2, which is when x equals negative 2. When you distribute this negative, then we're going to, the beta naughts will cancel out. This will become positive. We have 3 beta 1 plus 2 beta 1, and we have 5 beta 1. Now our beta 1 that we want to plug in here is the beta 1 from our regression that we ran earlier, and that beta 1 was 1.436. So we scroll up here, you'll see that indeed it is 1.436 right here. I'll go over and show you in SAS in case you don't believe me. In SAS, when we ran it, it's right there, 1.436. Lastly, we are going to cover the output that we got in SAS of the residuals and their standard error, and the residuals plotted against the ordered values of x, the residuals plotted against the fitted values, and the normal probability of the residuals. So in SAS here, bottom, we have the residuals and the residual standard error. That is right here, part I. Next, we're plotting the residual against ordered values of x. So we've got to scroll back. Here we have the residuals plotted against ordered values of x. A little difficult to tell what's going on, but pretty spread out. And residuals plotted against the predicted values. And then here, our normal probability. So we'll go over to our Word document and have the same graphs. They're a little nicer to read. right here. So there's our residuals versus x, the order values of x, and the residuals of the fitted or predicted values, and normal probability. And that is it. Thank you for listening.